Hello, everyone. Welcome to the March 28th, 2025 uh, Lunch and Learn. My name is Kerry Grable. I am the home horticulture educator for Purdue Extension, Marion County. I want to thank you for joining us and talking today about home soil testing for gardeners using EC and pH probes. Um, First of all, I wanted to apologize for having to record this in advance. My son is actually scheduled for surgery at the exact time we are supposed to be having our lunch and learn as a group. So I hope you'll forgive me for having to record a day in advance. But we shall get moving right along here. Let me get my PowerPoint pulled up here. Good. If we have not met, again, I am the home horticulture educator for Purdue Extension, Marion County. Uh, I work primarily with the Master Gardener program in Indianapolis, do other programming as well on just home gardening in general. If you're unfamiliar with Purdue Extension Marion County, we provide relevant and research-based educational services to Marion County residents and also organizations who share our passion for building young leaders, creating strong families, and healthy communities. So if you've not heard of Extension before, a lot of the folks will know us through the 4-H program, through the Master Gardener program, Ag and Natural Resources, helping farmers, things like that. And then also, we are committed to serving all communities in our town. And I always take this slide as an opportunity to say that if you are aware of a community that could use our support, reach out to us and let us know. We sometimes feel like the best kept secret in town, so uh, always help make those connections where you can and let us know of anyone that we could serve. So starting things off, I wanted to cover a little bit on soil pH and EC, which stands for electrical conductivity. I have spoken several times in the past about my use of soil probes and how I recommend doing so. But I wanted to go a little bit more in depth with this topic, with the science of how all of this works and why it's important in general. So starting again with soil pH and EC and why that matters to us. So soil pH by definition is a measure of hydrogen ion concentration in soil. So that operates on a scale from 0 being the most acidic possible, all the way up to 14 being the most alkaline possible, with 7 being neutral. So in the horticultural field, most of our things are going to be happy somewhere near neutral, 6 to 7. Most things will thrive in that range. There are exceptions. So our acidophiles are things like blueberries, our azaleas. They'll be happier down towards 5.5, maybe even as low as 4.5. Always look at recommendations for whatever specific plant is in question. And then there are plants that will tolerate soils that are a little bit more alkaline, which is a problem that we have here in Indiana. So lavender, lilacs, things like that will tolerate soils between 7 and 8 as well. So what does this do to the plant? Why does it matter? So a low pH, we could potentially see aluminum toxicity. There'll be nutrient deficiencies, which we're going to go into here in a second. Where a high pH, again, is going to be the reduced availability of things like iron, phosphorus, micronutrients. But we can visualize that using this chart. This is my favorite representation of how all of this matters to us. So down at the bottom, you will see the acidity scale, the soil pH scale there, with 4 on the far left and 10 on the far right. And then the bands indicate how available that particular nutrient is at any given pH. So if we go up at the top here, we can see that at 4, our nitrogen availability is very low, and then it broadens up and becomes more and more available as we approach 6. We go all the way to the other end around 8. It starts to taper back off again, and it becomes unavailable to the plant again at 10. So you can see how these ranges are important to us. Other examples with sulfur being unavailable down in the acidic side and more available as you go more alkaline. Calcium. So those of us with our tomato issues, you can see again, we have more acidic towards the left. It is unavailable. And as we approach neutral on into 8.5, it's nice and available to the plant. So that pH really affects how much of these nutrients that plant is able to take up in general. So a great example I love to use when discussing this is Hydrangea macrophylla. Very common landscape plant. A lot of us have it. And the question I always get is, why are they pink? Why are my blooms pink on my Hydrangea macrophylla? Why aren't they blooming blue? Well, this is a question of soil pH. So, if the soil pH is too high, so if we are in the 7.5, 8 range, then we are limiting that plant's ability to take up aluminum. Aluminum is what the plant uses to produce that blue pigment in the flowers of Hydrangea macrophylla. So the aluminum has to both be present in the soil, so there must be aluminum, and then the soil must be at a pH in which that aluminum can be accessible by the plant. So how do we address this? Well, we can apply aluminum sulfate. We are addressing both of those issues at one time by applying a product to the soil that acidifies the soil, and it also makes the aluminum present. If you want to get real fun with it, I have seen folks use this knowledge. So typically, you are able to maybe apply that aluminum sulfate to just one side of the plant. And if you do so, you will get a gradient from pink to purple all the way into blue as you move across the canopy of that plant, and the blooms will fade in color across it. So it's a fun way that we can use that horticultural knowledge about pH and aluminum in Hydrangea macrophylla to really fine tune and do fun things with the plant. So what about EC? Most of us have heard of soil pH. We understand that concept, but what is EC? This is one where folks have probably not heard of it. So EC stands for electrical conductivity, and that, by definition, is a measure of dissolved solids in a soil solution, indicating soil fertility and salinity. So salts is what we're measuring in this solution. And why does that matter to us? We think salt bad, but realistically, in the soil, the salts are, in this case, representing minerals. So we're talking about our macro and our micronutrients here. So we are capturing an overall snapshot of the mineral and salt level of that soil. So in this case, we are kind of making the assumption that the EC, the salts that we are seeing, are representative of the macro and micronutrients present in the soil. So by units, it's typically measured in either millisiemens per centimeter, which is denoted MS over centimeter, or decisiemens per centimeter per meter. So that's going to become relevant when we're looking at our EC probes in the soil. So you will, when you purchase a probe, the manual will tell you in which unit it reads. So using the millisiemens, we are going to see values like on the low end, 0.2. We're going to see nutrient deficiencies here. Optimally, for most plants, we're going to be around the 1.5 range. That's going to encompass a lot of plant material, and we'll talk about that in a second here. And then on the high end, if we're seeing 3 or above, that's too much. We're going to see some damage to the plants. We're going to see some root injury. So even our minerals that we are interested in having in the soil, our beneficial minerals, our macros and micros, if they are excessive, will cause salt injury to the plant roots and can desiccate that plant material. So again, low end, 0.2, somewhere in there, 0.5. If I see less than 0.5, I'm thinking, okay, that plant's hungry. Optimally, for a lot of plant materials, 1 to 1.5. And then if I'm seeing over 3, wow, that's pretty hot. I potentially have done some damage there. So let's break that down a little bit, just with a few different categories of plants and what we should be shooting for. Trees and shrubs are slower growing. They don't need quite as high of a reading in the soil for active periods of growth. So if I see a range of zero point 0.5 to 1.5, again, depends on how fast growing that particular woody plant is, that's going to be fine. That's what we're shooting for. That is a range that plant nurseries will use in their production, and they're happy if they see those things. Again, veggie crops, we are going to be more in the 1 to 1.5 range. If I see 1 to 1.5, I know I'm happy. I know my plant has all the minerals that it needs. I don't really need to address anything there. Now, if we are talking bedding plants, things that are rapidly putting on foliage, things that are rapidly blooming, I'm going to want just a little bit more. And that's a large category, so you can see my spread here is a little bit larger as well. But if I see 1 to 2, I'm pretty happy there. In the greenhouse setting, where they are really, really rapidly growing these plants and trying to push them out of that facility into your yard, they're probably shooting for 2.2 to 2.5. That's a little hot for the home landscape. You don't need to be shooting for 2.2 to 2.5. But in the landscape, if I see 1 to 2 in bedding plants, I'm pretty happy with that. Increasingly so, you will see that some plant breeders will provide this information to you on their website, their target EC in the soil. This is very useful to nurseries and greenhouses that are producing them, but the home grower can use this information as well. So if you can determine which of the major plant breeders has the patent on whichever plant variety is in question, you might be able to pull up that website and then see what it is that they are recommending. Uh, so always do that research when at all possible. If you're going to go through this process, if you're going to bother with taking a measure of your soil fertility, then do your research and see if you can't find recommendations on it. It's not going to be there for every plant out there. You will frequently strike out when looking for research-backed information on this. But using some of these broad categories up here that we have at the top, that might hone you in a little bit. That gives you a general sense of what we want our soil EC to be. I wanted to throw this in because when looking at meters, this is a term that you're going to come across. So in our scenario, this isn't relevant. So total dissolved solids is if you get a combo probe that has pH and EC, it will also frequently have total dissolved solids. And so that measures the total amount of dissolved substances, both conductive and non-conductive in a liquid. So there we're measuring more than the mineral content of the solution, and so that's not representative of the nutrient content of that soil. So that's not what we're looking for, but it is a frequent additional setting that you'll find on those meters. It's just not one that we're going to be using. So you can ignore the TDS setting on these probes if you happen to come across it. Stick with EC if you are trying to get a snapshot of the mineral content of soil. Okay, so let's talk about some soil probes. There's a lot of them on the market, so it can be intimidating to get into. So hopefully I can give you a little bit more information on the different kinds that you might run into. So starting with types of soil pH probes with the analog probes. So these are the metal probes that estimate the soil pH based on electrical resistance. These are the cheaper options. No batteries required. Again, this is going to run off of the charge in the soil, so very simple tools. On the con, it's less accurate. So you can see a zero point 0.5 pH variation is a pretty big variance when you're taking a reading. That 0.5 could make all of the difference in the world. So not the most accurate thing out there. You can't calibrate them. And then they can be affected by the soil moisture and the compaction. So there's more that could influence your reading here. So again, accessible expense wise, you might get into these things around $30. Prices are always changing, so it's very hard to give you a price estimate on these things nowadays. But again, this is your entry level with the knowledge that it might not be all that accurate, and it might have some outside influences, but it might get you in the ballpark of accuracy there. Moving on to the digital handheld pH meters. So these are using a glass electrode that measures the hydrogen ion concentration in a soil slurry. We'll talk about that briefly. So much more accurate to within zero point zero 0.01 to zero point 0.1 on the pH scale. So this is going to get us much closer to what our true reading is. They can be calibrated. This is important because, as the probe ages, it may need calibrating. So this has the option to be calibrated. However, it does kind of need to be done frequently. So that is the con side of the calibration. There are various solutions that you will have to purchase, inexpensive, that you will have to run a calibration setting at various standards so that the machine can recalibrate itself. The electrodes can be broken if you don't handle them properly. They do need batteries. Although on my own personal probe, I don't think I've changed the batteries on this probe since I bought it. So they do last a very long time. Um, there is a little bit more maintenance in terms of how you store it. When you get into these digital probes, you need to be much more careful about properly storing them. If the probes dry out, that can be a problem. The probe could go bad. A lot of these units, the probes are replaceable. So these are going to be a little bit more on the expensive side, these digital probes. But the benefit being that you have the option to replace just the probe and not the entire unit. So a little bit more of an investment. You're getting more accuracy for that. You're getting that calibration effect out of that. But you've got to pay a little bit more attention to the unit. Moving on to EC probes, there are simple EC testers. So again, this is kind of talking about those TDS pins and the EC meters. Frequently, we'll do both of those things. They have two metal electrodes that measure the conductivity of soil in a solution. On the EC side, these are the affordable guys. Very easy to use, very simple, and we'll go through that procedure in terms of what a soil test looks like. They don't require a ton of calibration, but again, on the con side, we're back to that accuracy question. Limited accuracy. So if we're talking ranges of 0.5 to 1 and our variance is up to 0.5, that's a pretty big variance. That's not terribly accurate. And they can't really do dry soils, so they do require a soil water slurry. So these are the more common units that you're going to see. So here we have combination pH EC meters. So these are all in one. They measure both pH and electrical conductivity. Again, they have those interchangeable probes. They are dual function, so it saves the time. It's an all-in-one unit. You're not swapping back and forth between these units. Less storage space. ATC is talking about automatic temperature compensation. Temperature can affect some of these readings, so having a unit that compensates for that is great. We're back to the expense again. So some of these units are $150. Some of these units are all the way up to $300. My unit is kind of right there in the middle, around $200. They used to be less expensive like everything else, and they have gone up. So you do, as a gardener, if you're investing in something like this, you're going to have to be pretty serious about doing these tests. You're going to have a real desire and a real need to know what's going on with your soil pH and your soil EC. The expense, I think, is at least partially offset by the fact that it is a 2-in-1 unit. So you are getting two probes in one. And then again, there's maintenance that has to be done on these guys. You got to store them properly, protect your investment. A lot of times I keep saying, you've got to keep that probe moist. There's a cap on here that comes off, and I will just keep a piece of sponge down in there that I keep moist, and that's enough. It doesn't have to be wet. It just has to have a moist environment So the maintenance side of it, it's not terrible, but it is a consideration that you have to think about. So that's kind of a high overview of the different types of probes. Should anybody decide after watching this presentation that you're interested in kind of pursuing this path and getting a probe, reach out to me, talk to me. I'm happy to talk about probes with you. I have lots of experience doing these tests. I've been doing these tests for the better part of 10 years. So I can walk through that process with you. So, speaking of tests, how do you do them? So let's talk about how to conduct a soil pH and EC test. Starting with soil pH, a slurry test is the quick and easy way to do it. And it is very, very simple, very easy. So first you have to collect your sample, very obvious. And that's really going to depend about what it is you want to know. So do you want one representative area, do you want one representative sample from an entire area? Or maybe you have a smaller raised bed that you want to know what's going on with it, all the way down to a container. So very, very, very simple. If you're doing a container, you might just take one or two little soil samples. If you're doing a raised bed, I might do 3 or 4 across that raised bed, depending on the size. If I'm doing an entire garden area, you might increase that up to 6 or 8 small samples. We're going to homogenize that together. The depth you're taking it from, think about where the roots are. That's how deep you need to be taking the sample from. So again, you see there for lawns, 3 to 4 inches deep. For a garden, around 6 inches. That's fine for most veggie crops. So take samples that are representative of the area in question and then homogenize that together. So you're going to mix that with distilled water. Read your probe instructions. It'll tell you how much to use. So it's either 1 to 1 or 1 to 2. But typically, I've got a cup, I've got my soil in it, I'm going to add the water, and I don't want it super, super loose with water. I'm just trying to kind of make a little bit of a mud, a slurry. And I want to be able to create a divot in the soil that fills with water that I can stick that probe down into. And that's where I'm going to take my reading. It's going to mix it with that distilled water. Why distilled water? Well, if I use distilled water, hopefully it's not going to be influencing the test in any way because the water is kind of an extra variable. But if you use that distilled water, it's going to kind of eliminate that variable. So you stick that probe into the slurry, and you allow the probe to stabilize. It can take some time. After 10 years of doing this, I really don't know what the logic is behind how much time it takes for that probe to stabilize, but it can take sometimes upwards of a minute sometimes. But when it stabilizes, that is your reading. So this is great. This is super fast. This is super easy to give you a quick and dirty look at, no pun intended, at what your soil pH is in any given spot. So pH is kind of my go-to a lot of times. I've got a plant, there's a problem with it. I don't see any obvious signs of diseases. My first thought is, what's going on with the soil? And pH is the first thing that pops into mind, and that is how easy it can be to test. You can do this all day long in your own yard, very quick, very simple, on property, all at once. You don't have to send the test off. So very, very simple to do. Moving on to testing EC, that electrical conductivity. So it's basically the same procedure. So we're gonna do that same collection of soil samples, mix it with deionized water again. Again, deionized water is much preferred. So with soil EC, the electrical conductivity of deionized water is 0. We're adding nothing to the equation when we're using deionized water because there's nothing in it. And so by using deionized water, all that we're going to be reading is what is in the soil and nothing else. Now, if you don't have access to deionized water, what you can do is just use normal tap water. So first, I'm going to get my cup of tap water, and I'm going to read the EC in that. Then I'm going to do my test here. But I need to remember to subtract the EC of that tap water from whatever I read, and that will account for the EC that we've added in with that tap water. So it's preferred to use the deionized, but if you don't have it available to you, again, you can just subtract that EC reading from your tap water and that'll account for that and remove that from the equation. So again, make your slurry mixture however the probe requires. Immerse that EC probe into that slurry, and then again wait for that stabilized reading. So we've already kind of discussed what some of these readings mean, but if I'm seeing point 0.2, if I'm seeing less than 0.5, really, I'm going to start thinking I've got nutrient deficiency here. So that's what's going on with my plant. My fertilizer has run its course. There's no nutrients available to that plant. I need to amend in some way if I expect that plant to continue to grow. So if I see 0.5 to 1.5, I'm happy. I'm probably not going to make any adjustments with if I'm seeing 0.5. I'm certainly very happy if I see 1.5. That's a good, healthy growing condition. There's plenty of nutrients left for that plant to grow. And then if I'm seeing 3, 2.5, 3, okay, now I know certainly don't add anything. I need to think about mitigating some of that potential root damage. So that's the simple EC test. Again, always happy to run through this test with folks. I've been doing these tests for years and years and years. They're very, very simple once you know how to do it. And it is such a great decision-making helper for you out in the garden space. So what about if I have a container and I don't want to knock that container over and start taking soil chunks out of it, which is an option, but what if I don't want to do that? Well, there is the pour-through leachate extraction technique. Short term, it's a pour-through. So this is a way that we can use these pH and EC meters without disturbing the contents of a container. So you'll need your meter, you'll need the plant container in question, you'll need a collection saucer, so something that container can sit down in to collect water underneath it, and again, some water to test it with, preferably distilled, but if you don't have distilled, again, we can do our little math trick there. So step 1, we're going to irrigate that container as normal. So do a full irrigation on it, and then we're going to let it set for about half an hour. The research used to recommend that you wait upwards of 2 hours after you irrigated. Well, somebody came along and did research that proved that there was no statistical difference between waiting 2 hours and a half an hour. That's me. I did that research at the University of Kentucky. So wait about half an hour to allow that water to normalize with the conditions in the pot. And then you're going to place that pot into that collection saucer. You're going to pour on a small amount of distilled water onto the top of the container, just enough to push that water that we put on half an hour ago out the bottom, just enough to push on a readable amount of that water out the bottom. And that collects down in that saucer. And so then we can take a reading in that saucer, and that leachate, that water coming out the bottom, it will have sat in that container long enough that it will have normalized, and it will be very representative of what is going on in that container. So you can take your pH reading and you can take your EC reading on that. And that way you know what the fertility conditions are within that pot. I spent many, many, many summers doing pour-throughs in nurseries across Kentucky. So it is a very accurate method. It is the method that nurseries use out on their properties to know that their fertilizers are still running. Okay, so we have our readings. What do we do with them? Well, hopefully we're going to take that data on board and we are going to do something with it and make some changes, right? So if we see a problem, let's do something with that. So starting with pH, adjusting pH can be hard. So particularly if our goal is to make our soil lower in pH, more acidic, we have options, but it is difficult. It can take much, much sulfur into the soil for very, very small adjustments. So this is a long-term process. This is an overtime process. So again, we have that elemental sulfur for lowering pH. We've got organic matter. Adding organic matter to the soil can help lower it. Acidifying fertilizers might be an option. So, again, very small changes are going to be made over long periods of time. For raising pH, probably not going to be a need here in Indiana. We've got our calcium soils, um, but there's a few areas of the state that this might be an issue. So we can add lime and wood ash, but make sure you're putting on the correct amounts. So make sure you know your soil textures. Make sure you're doing the proper amounts when doing so. A little bit more straightforward when we have our EC levels and we need to know how to adjust it. For reducing high EC, so this is a buildup of salts, too much fertilizer, we need to leach. We need to leach. So we're going to be putting on large amounts of water to see if we can't flush some of that salt away. Again, organic matter to improve the soil structure is an option, but the quickest and most straightforward method is definitely leaching some of those salts out of that soil. So in a container, that would be making sure water is running out of the bottom of that container each and every time you water it. That will help prevent that buildup of high EC. And the soils, it's just flushing that soil as much as you can. We're not going to try and drown the plant. You need to have those drying events so that those roots are still getting some air to them. But we need to have those flushing events to try and move some of those salts away from the plants. Increasing low EC, fertilize, right? We're just adding nutrients to that equation. So that would be our fertilizers, that would be our compost and manure, things like that. So I really wanted to throw this in here, talking about controlled release fertilizers. This is where these EC tests really shine. So a little bit first on controlled release fertilizers. These are products that are designed to slowly release their fertilizer over time. They're contained in a resin prill. Most of them are resin. So the prills are those little balls you see there in the container. And the formulation of that resin coating determines how long that product is designed to last. So you see in our example image here, other products are definitely available. But in our example image here, you see feeds for 4 months. Now, there's some small text there that we need to be aware of. So longevity is advertised in months, and the fine print is at 70 degrees. If you've spent a single summer in Indiana, you know that we get a lot warmer than 70 degrees. So, what does that mean? Well, again, speaking of my research at the University of Kentucky, uh, here we go. We have, in this example, um, slow release fertilizer that was advertised as a 5 to 6 month blend. So you see this was in Green Mountain boxwoods in containers. Um, and so you can see over the course of this summer, we took readings. This is June 26th, pre-fertilization, and then after fertilization, a couple weeks later, we're up to about 1,001 in our unit that we've been using. And then this green band indicates, again, we said for woody plants, Green Mountain boxwood is a woody plant. We wanted 0.5 to 1, and we were pretty happy with that. So that green area represents that. And so you can see in October, after only 4 months, we have now dipped below our desired fertility range that we wanted in our woody plants. So our temperatures will speed the rate at which these products release their fertilizer, and so their longevity is going to be affected by that. But how would we know that? We know that with this soil EC testing. That is what these meters are used for. So this is a monitoring tool. Um, when you start mid to late summer seeing that purpling start to show up in your tomatoes, test the soil. So look at what is going on in the soil and see that you have adequate fertility left in that soil. And if you do not, now it's time to come in and start applying additional fertilizers. Um, I always encourage you all to keep a gardening journal and start to write this information down year after year after year. So these products are going to be very influenced by their environment. We just had this conversation, and the environment in every garden is different. So you have to know your property. You have to know this portion of the property in which your garden is. So if that location on your property heats up extra, then your fertility might drop off soon. So keep notes of how long that fertilizer lasted throughout that summer. Um, and use that information year to year. Know that, okay, last year this product that was advertised for 4 months only lasted 2 months. Okay, 2 months after I applied it, I now need to go back in there and start testing that fertility to see if there is enough fertilizer to last me the season. That is what this tool allows you to do. So this has been kind of an overview of what this technique can do for you. I know this is just an introduction on this topic. I'm sure it probably left you with more questions than it answered. But again, I am here as a resource. I have done this technique. I have used these meters for years and years and years at this point, and I'm always very happy to talk about it and talk about how you can fit this into your gardening technique. So be sure to reach out. Let me know if you have any questions on that. I know that with this being a recording, we do not have the ability to have a discussion now that we are at the end of the presentation. Again, I apologize for having to pre-record this, but reach out with your questions. Let me know what you would like help on. If anybody wants to undertake this summer, I can help you look at meters, and I can help you with getting your first test set up. Very, very easy, very simple to do. And I really do think that it can help with your gardening in the future. So with that, I am going to end us. I thank you for joining me, and I hope you learned something today.